Hello everyone, welcome to week 4 part 3, class hierarchies. We talked in part 2 about the classes and the different types of classes like such as the base class, the derived class, or the child child parent classes. Um, in this case, we have a base class that can be derived from another base class. For example, you have class C that can be derived from class B, which is derived from class A. Consider the graded activity, the final exam, pass-fail activity, pass-fail exam hierarchy on the right side of the slide. So here you have pass-fail exam, which is a base class from pass-fail activity class, which is a base class of the graded activity class. Also notice that the graded activity has two derived classes. So that brings us to the discussion of polymorphism. Polymorphism concept means having many forms. It occurs when there is a hierarchy of classes and they are related by inheritance. So in C++, polymorphism means that a call to a member function will cause a different function to be executed depending on the type of object that invokes the function. Polymorphism is generally used by having each of the child classes has a separate implementation for the parent class function. Virtual member function is a function in base class that expects to be redefined in derived class, and the function defined with the keyword virtual. So, for example, you have to define a virtual class, you use virtual void y. Support dynamic binding functions bound at runtime to function that they call without virtual member functions. And C++ uses static um, compile time, static compile at compile time, or static binding. Consider this function the display grade. Because the parameter in the display grade function is a graded activity reference variable, it can reference any object that is derived from the graded activity. That means we can pass a graded activity object, a final exam object, a pass-fail exam object, or any other object that is derived from the graded activity. So polymorphic behavior is only possible when an object is referenced by a reference variable or a pointer, as demonstrated in the display grade function. So however, as you can see here, a problem occurs in this program. As you can see from the example output, the get letter grade member function returned C instead of P. This is because the graded activity class get letter grade function was executed instead of the pass fail activity class's version of the function. So a virtual function is dynamically bound to calls at runtime. At runtime, C++ determines the type of object making the call and binds the function to the appropriate version of the function. To make a function virtual, just like we mentioned before, place the virtual keyword before the return type in the base class's declaration. The compiler will not bind the function to calls, instead the program will bind them at runtime. On this example, notice that the function is now virtual on line 27. The function becomes a virtual in all derived classes automatically. If we compile our program with the updated version of the classes, we will get the right output shown here. So this type of behavior is known as polymorphism, and the term polymorphism means, again, the ability to take many forms. This program demonstrates polymorphism by passing objects of the graded activity and pass-fail exam classes to the display grade function. This is continuation of the program, and notice the program output for the two tests that the program ran, test 1 and test 2. Base class pointers, we mentioned on slide 2 that polymorphism requires references or pointers where polymorphic behavior is only possible when an object is referenced by a reference variable or a pointer, as demonstrated in the display grade function. So base class pointers can define a pointer to a base class object, and it can assign it to the address of a derived class object. Base class pointers and references only know about members of the base class, so you can't use a base class pointer to call a derived class function. And the redefined functions in the derived class will be ignored unless base class declares the function virtual. Abstract base classes. What is an abstract base class? Basically, an abstract base class is a class that can have no objects, serves as a basis for derived classes that may or will have objects, and the class becomes an abstract base class when one or more of its member functions is a pure virtual function. So abstract base class is a class that have no objects. It's a basis for the derived class that could or could not have objects, or may or will have objects. And when you ask yourself when a class becomes an abstract class, basically when one or more of its member functions is a pure virtual function.